Hello, Matt here from ChemistryStudent.com. In this video, we're going to look at permanent dipole-dipole interactions. We're going to talk about what permanent dipole-dipole interactions actually are, how they form, and the factors that influence the strength of such interactions between molecules. Before we talk in detail about permanent dipole-dipole interactions, there are a few essential ideas you need to be comfortable with. Covalent bonds are atomic bonds that form when two atoms share a pair of electrons. An atomic orbital from each atom overlaps and creates a new area of electron density between the two atoms. The positively charged nucleus of each atom is attracted to the shared electron density, and this pulls the atoms closer together, creating a covalent bond. Inside a single bond, there is one pair of electrons. Molecules are groups of atoms covalently bonded together in units that make up molecular substances. Intermolecular forces are forces of attraction that arise between molecules within a molecular substance. It is intermolecular forces that get broken or overcome when a molecular substance melts or boils. The stronger the intermolecular forces holding molecules together, the higher the substance's melting and boiling point. Electronegativity is the ability or tendency of an atom to attract a pair of electrons in a covalent bond towards itself. Atoms of elements with a higher electronegativity than the atom they are covalently bonded to can pull the electron pair towards themselves slightly. This gives the atom a partial negative charge and the other atom in the bond a partial positive charge. The bond is described as being polar, as it has a positive end and a negative end. The size of the polarity in partial charges is based on the difference in electronegativity between the two bonded atoms. The larger the difference in electronegativity values, the more polar the bond. Electronegativity increases for elements as you go across a period in the periodic table and decreases as you go down a group. Recap done, let's go. Permanent dipole-dipole interactions are a type of intermolecular force that exists between polar molecules. They are stronger than temporary induced dipole-dipole interactions or London dispersion forces. Covalent bonds can be polar if the two different atoms bonded together have different electronegativities. The atom with the higher electronegativity will pull the electrons in the bond towards themselves, giving them a partial negative charge, and the other atom a partial positive charge. The bond is now described as polar and has a dipole moment. One end partially negative and the other partially positive. A bit like a bar magnet has two poles, north and south. The electronegativities of the atoms don't change, meaning the bond is constantly polar. The electrons, although constantly moving, are more likely to be found closer to the atom with the higher electronegativity. This makes the dipole permanent, unlike with temporary dipoles that only arise through constant and random movement of electrons. The greater the difference in electronegativity between the two atoms, the more polar the bond and the greater the partial charges on each atom. Molecules that contain polar bonds and are unsymmetrical are polar. This is because the electron density across the molecule is unequally distributed, and the overall dipole moment is created. One part of the molecule becomes partially negative and another part partially positive. If a molecule is symmetrical, even if it contains polar bonds, it won't be polar overall, as the electron density will be equally shared across the molecule, given no dipole. For example, carbon dioxide, CO2, contains two CO bonds, both polar. The molecule is symmetrical though, meaning no overall dipole exists, as both polar bonds cancel each other out and pull the electron density in opposite directions. A bit like a tug of war between two people of equal strengths. There is no winner. Permanent dipole-dipole interactions can only form between polar molecules. If two neighbouring polar bonds from two different molecules get close enough to each other, there will be attraction between the oppositely charged regions of each bond or molecule. These attractions are referred to as permanent dipole-dipole forces or interactions. The partially negative end of one molecular bond is attracted to the partially positive end of the other molecular bond. Unlike London dispersion forces, this attraction force is permanent, making them stronger, longer lasting and harder to break, increasing the melting and boiling point of a substance that can make them. The strength of the dipole-dipole forces are based on the polarity of the molecules or bonds interacting. The greater the polarity, the stronger the dipole-dipole interaction, and the harder it is to separate the attracted molecules. Be careful though, as remember all molecules still have temporary induced dipole-dipole interactions between them. This means with some substances you have to consider the effects of both when talking about their melting and boiling points. For example, hydrogen chloride, HCl, is a more polar molecule than hydrogen bromide, HBr. This is because chlorine is more electronegative than bromine. This means the strength of the permanent dipole-dipole interactions between HCl molecules is stronger than between HBr molecules. As a result, you would expect HCl to have a higher melting and boiling point than HBr. This isn't the case though. HCl has a boiling point of minus 85.5 degrees Celsius and HBr has a boiling point of minus 66 degrees Celsius. To explain this, we also have to consider the temporary induced dipole-dipole forces between the molecules. For these intermolecular forces, the bigger the molecules, the stronger the temporary dipoles and the stronger the attraction between them. Bromine atoms are much larger than chlorine atoms. This means that HBr is larger than HCl and the strength of temporary dipole-dipole interactions is stronger between HBr molecules compared to HCl molecules. This increased strength offsets the weaker permanent dipole-dipole forces between molecules and explains why HBr actually has a higher boiling point than HCl, even though it is a less polar molecule. So, to summarize, permanent dipole-dipole interactions are a type of intermolecular force that exists between polar molecules. They are stronger than temporary induced dipole-dipole interactions, or London dispersion forces. Covalent bonds between atoms with different electronegativities are polar, creating a dipole moment across a molecule that isn't symmetrical. Charges from one dipole can attract the opposite charge of a dipole from another molecule. These attraction forces hold the molecules together and need to be overcome or broken to melt or boil the substance. The strength of a dipole-dipole force is determined by how polar the bonds in the molecules are. The greater the polarity of dipoles, the stronger the dipole-dipole forces and the higher the melting and boiling point of the substance. I hope you found this video useful. Please check out other relevant videos in the links given in the description below and visit chemistrystudent.com for free notes and revision materials.